Hi there, and thanks for tuning in. Today we're looking at lesson 14.5, using the Pythagorean Theorem and the distance formula. Today we'll be looking for 8 things in our notes, so let's go ahead and get started with number 1. The first thing we're going to write down is just a reminder of what the Pythagorean Theorem is, and actually the converse statement of the Pythagorean Theorem. It says if the equation a squared plus b squared is equal to c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So basically, if you can plug in a squared plus b squared and it does equal c squared, that means yes, it would be a true right triangle. Let's just go ahead and make sure we are reminded about this statement right here. So let's go ahead and write down this for number 1. So we're going to pause the video here, and once you're done writing this statement down for number 1, go ahead and click play to try number 2. So this is exactly what you're going to be doing in number 2. You're going to be telling me if the triangle is a right triangle by using the Pythagorean theorem. You again want to use a squared plus b squared is equal to c squared and plug in your number values to see if it actually is equal to one another. Go ahead and pause the video now to see if the statement is true, and once you're done, click play after working it out. Okay, for this one I said 9 was A, 40 was B, and 41 was C. Remember, C is always going to be the biggest number that you have on your triangle because it's the hypotenuse. So I would write 9 squared plus 40 squared is equal to 41 squared. I know 9 squared is 81 and 40 squared was 1600. I did have to do some work for 41 times 41, and that does give me 1681. And as you can see, 81 plus 1600 does equal, 1681. So we would say, yes, this is a right triangle, because a squared plus b squared equals c squared. Okay? Number 3 is the exact same way, except this time it doesn't give you a picture of it. Here are your lengths, 18, 12, and 24. Just remember, C is always the longest length in the end of the event that you're given lengths for a triangle to see if it's a right triangle. Let's go ahead and pause the video here for number 3 so you can try it, and once you're done, click play to check your work. Alright, so what I did is I plugged in 18 for A, so 18 squared. B squared, I said 12 squared, and then 24 squared was c squared. Okay, I did have to do some work for 18 times 18. That's going to give me 324. I know 12 squared is 144, and I did have to do some work for 24 times 24. 24 times 24 is 576, so I just make sure it is 324 plus 144, 576. Obviously, it's not going to give me that, so we're going to say no, because a squared plus b squared does not equal c squared. Okay? The next thing we're going to write down is the distance formula, and the distance formula between any 2 points on a coordinate plane. If you're using x1, y1, which is one set of order pairs, x2, y2 is another set of order pairs, you can plug in those values into this formula and then solve it. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. Go ahead and take the time now to copy the distance formula exactly like you see it, this whole entire statement. Please make sure you copy it carefully. We are going to be working out some of these questions for the remainder of the notes. Alright, so what I'm going to do first is show you how the distance formula works. The first thing you're going to find is you're going to be given 2 points, and it's going to say find the distance between these 2 points. Okay? What I always like to do is whenever I write down the points in my notes or on the paper that I'm working this out on, I always start with the first one and say the first one is the first set, so that's x1 and y1. And then the second one is always going to be x2, y2. Remember, in the event of ordered pairs, x is always listed first, so that's why it is in that order. Okay, x1, y1 is the first set, x2, y2 is always the second set. It really doesn't matter what you choose, but for the sake of understanding and make sure you're thorough, we're just going to say the first set's always the first one, second set's always the second one. Then I'm going to take the distance formula and plug in my values. It says for the distance, x2 minus x1. So that's negative 4 minus 1 squared plus y2 minus y1. So that'd be negative 2 minus 5 squared. Okay? I do know that negative 4 minus 1 is actually negative 4 plus negative 1. So that's going to be negative 5 squared. And negative 2 minus 5 is actually negative 2 plus negative 5. So that would be negative 7 squared. Negative 5 squared is a good thing because that's going to give me 25 as a positive. And negative 7 squared will give me 49 as a positive as well. All I have to do now is just add these two together and see if I get a square I can solve. 25 plus 49 is 74, so I'm going to write the square root of 74. Since this is not a perfect square, you can keep your answer just like this. If this was a perfect square, then you would be able to change it to whatever the square root was. Okay? Here's one that you are going to try. I'm going to start you off on this one. We're going to say that 0, 0 is x1, y1, and 4, 5 is x2, y2. Okay? Go ahead and pause the video now. Plug in the numbers for x1s, y1s, x2s, y2s in your distance formula to solve it. And then once you're done, click play. You will have just a square root again as your number here. Alright, so we should have already done this. This is you pressing play to check your work. We are going to go ahead and plug in x2 minus x1, which means 4 minus 0, and then square it, plus 5 minus 0, because that's y2 minus y1, and then square it. These are pretty easy. 4 minus 0 is 4, so I'm going to have 4 squared, plus 5 minus 0, which is 5 squared. 4 squared is 16, and 5 squared is 25. And I'm going to add those two together. I am going to get 31, and then keep that square root symbol. I cannot find the perfect square of square root of 31, so I'm going to leave my answer just like that for number 5. Here's another one for number 6. Please be careful on this one, and remember your keep, change rules whenever you subtract a negative. Okay? Let's go ahead and pretend x1, y1 is the first one. Not pretend, real life here. And y2, x2, y2 is the second one. Let's go ahead and pause now so you can try it, and once you're done, click play to check your work. Alright, we're finding the square root of x2 minus x1, so negative 5 minus negative 2 squared, plus y2 minus y1, 1 minus negative 3 squared. Keep in mind, whenever you see negative 5 minus negative 2, that actually means negative 5 plus positive 2. And 1 minus negative 3 means 1 plus positive 3. Negative 5 plus 2 is negative 3 squared. And then 1 plus positive 3 is going to be 4 squared. I know negative 3 squared is 9, and 4 squared is 16. And 9 plus 16 actually does give me a perfect square. It's going to give me 25. I can find the square root of 25, so my answer for number 6 is equal to 5. Here's again number 7. Again, go ahead and try this one. Let's pause the video here, try it, and then once you're done, click play to check your work. Alright, so we have x1 and y1, x2 and y2. It's so important that you label those, okay? In your distance formula, we're going to do x2 minus x1 first, so 9 minus 7 squared plus 6 minus negative 3 squared. Again, 6 minus negative 3 actually means 6 plus positive 3. 9 minus 7 is going to give me 2, so that first one will be 2 squared. And then 6 minus negative 3, or 6 plus 3, will be 9 squared. Okay, then we're going to continue working on that. 2 squared is 4, and 9 squared is 81. And you're just adding 4 and 81 together to get 85, keeping the square root sign because there is no perfect square for the square root of 85. Last one, here's number 8 in your notes. Again, let's pause the video, find the distance between the 2 points using the distance formula, and then click play when you're ready to check your work. Alright, we said negative 4 was x1, y1 was 6, and x2, y2. So we'll have x2 minus x1 first. So 3 minus negative 4 first, squared, plus y2 minus y1, negative 2 minus 6 squared. Remember your keep, change, 3 plus positive 4, negative 2 plus negative 6. 3 plus positive 4 is 7, so 7 squared. Negative 2 plus negative 6 is negative 8 squared. Then we've got 7 squared, which is 49, 8 squared, which is 64, and then we're just going to add those two together. 64 and 49 make 113. That is not a perfect square, so we can leave it right underneath that radical symbol or the square root symbol. And so the square root of 113 is your answer for number 8. That's going to conclude our notes for today. Thank you so much for tuning in. If you need a little bit extra help on the distance formula, just go back and try to look at the other questions or come see me in class. Have a great day.